Session I'm going to teach you how to make the enemies smart so you can avoid the obstacle and they can come close to me and also hit me and make me to lose health. I made this in two parts. So in this session I cover the enemies that do the melee attack, and in other session I cover those enemies who does the magic attack. So we have the enemy that has the enemy holder and the enemy with different sprites. Let me move them. This, but this one I added because I needed to animate that. Because to save some time, I already animated my enemy. This is the attack. Let me show it here. This is the death animation. For death, I just made all the sprites to shatter, I just moved their transform and rotation. For example, I brought this head, this hand in here down to this position, for example, and rotated it. And I did it for all different parts of the enemy, which has a sprite on them. And also on the end, I just changed for all of them, I just changed the color. For example, here it was white. Here I changed this. It's gonna fade in effect, in a black effect, and also here it just fades. And I changed the opacity to 0. Okay, so that's it. And also, if you look at the collider, as the enemy falls, is shattered and goes on the ground, the box collider also shrinks. You can do that by, okay, you just put start recording and then go here and just click on that and change something to make a keyframe. And here, um, again, just move this and bring it down. So it would make another keyframe for you. So when the enemies comes to this space, the player can jump on that. So, and here we write a code that it completely disappears and it destroys all the thing. You can do different things. For example, you can make it deactivated so the player can go through that. But if it has a rigid body, which mine has, um, which I'm going to later add, that you have to also deactivate the rigid body in the, or make it at least a static so the gravity wouldn't pull it down. But for mine, I thought that that was better. And also I have hurt animation when the player is hurt. And also the idle and the walking or running animation, which I've told you how to do that for the on the player animation session. So I have this. So what we're going to do for this tutorial? I want that to give the enemy AI to make it smart. So, for example, if the my player is far from him, he wouldn't see my player and does nothing. And when my player, for example, comes here in the grass place, he would be aggroed and come towards me. And when he's very close to me, he would attack me. Okay. And to make it more, to clarify it even more, imagine that I have this. So this is a distance that the enemy is aggroed and would be aware of the player presence. For example, if the player is here, the enemy does nothing. But if the player comes here, then he knows, okay, I saw the player. He's intruding. I have to go towards him, and when he is in a certain distance, he stopped there because I don't want that. Okay, he just goes then eats him. So he would stop there at this distance, and starts attacking. All right. And again, imagine that my player goes away and flees, so he wouldn't follow that. You can make your code to chase a player, but imagine that he doesn't follow that. So um, there are two important things. That is the you kind of say that it is line of sight, and this is the attack distance. So let's go and write in the code. So for your enemy, I'll of course you need a box collider 2D or any kind of 2D collider, and I want that it will react to gravity, so I give it the rigid body. Don't forget to freeze the rotation on Z, so it wouldn't, for example, rotate, or something crazy happens. And this, so you go to enemy, and I think it was for the dummy here. So I make, and I say enemy AI, which is both for movement and attack. And here, so we want to, at first, the enemy has to calculate the distance between himself and the player. So we need the player, we need the position of the player. So I say private game object player, and I have to say that, okay, find the player here, define that. I say game object. I'm looking for a game object. That's find game object with tag player. I said, okay, this player is a game object that has a player tag, which is this. Okay, now we can go and let's say, for example, I'll make it serializable for the distance detecting int. I say, for example, side distance. For example, I want that if the player comes to 12 distance from the enemy, my enemy sees that, and to be aware that the player exists, that is this, and he would react or coming towards that or shoot something. Okay, so that's it. And also I make it serializable, so you can change it for different enemies. So you can use the same code, but you just change the number for different types of enemies. And I say here it has to stop and does the attack animation. So I say here scene stopping stop distance. For example, I said 2f to 2 because that is the integer. For different models, you have to see, for example, maybe this is too much and 1 is also very low. You want to make 1.5, so you have to make it a float. Let's make them float. Okay, so we have this, and now let's go there and calculate the distance between player and enemy. But how? So we say float distance from player. So vector 2, that distance, you just calculate between, for example, this parameter and this parameter, okay? It calculate distance between two things. For, I say transform the position, which is the enemy, because I'm going to give this code to the enemy. And also, yes, play and the player transform that position, okay? And then we check that um, if this distance is more than this, then it has to do nothing because the player is not in his sight. Is more than sight distance. So we say, okay, just idle. If I want to explain it here, it means that, okay, the player is here. Okay, so the enemy is not aggroed. But else if distance is lower or equal to sight distance, it means that, okay, you came close to me and I see you. Then it has to do something. And also this distance must be bigger than the stop distance. Then this, for example, the enemy is here. Okay, it is aggroed, it comes toward the player. And as I've told you, it shouldn't go inside that. It should stop also here. So that is it. I mean that this distance. I want to calculate this, which is of course less than the site, but also more than this, something like that. Then it's just goes toward the. It means running. It just run or walk towards the player, but it doesn't attack. Then else if what is that? And then else if the distance from player is more or I'm sorry, less or equal to stop distance, it means that the enemy, what is that? It's kind of here, very close to the player. Then it shouldn't go any further. It has to stop there and just attack. All right, so we have this logic here. Outside the update function, let's write private void. I want to make the moving, move towards player, and I use this function in here. So I say transform that position would be vector 2 move towards, okay, from where, from your place, whatever that is, towards whom. So that's the current position is the position of the enemy, and the target is the player position. Player. That's transform. That's position. And I want to give it a speed. Serialized fields, private, int speed, for example, 2f. 2, I'm sorry, 2, because it is integer. But for the float, you can use this. So by the speed, and as it is the transformed position, we need to multiply that by time dot delta time. Time dot delta time. So that is for moving. So idle, it means that, okay, stop moving. Or being idle, stop moving. It means that, okay, does, for example, we set the animation to the idle. I make the run animation to false, which later we will do that. Or you can directly say that here, but for the clarity, I use these small functions or methods. And here we want to make a function for attack. Private void attack player. And do you remember that for player what we used for attacking? We go to the melee. Okay, we had, for example, the physics studio overlap. We just set, okay, um, we set an attack point and also a range. So that's the, something, a circle. So everything that connects to this circle or it is inside that would get hurt. So we had a point, a position, and then we set the range and say, okay, everything that comes into that circle, if it has the, for example, tag of the enemy, it would be hurt. So, and then we do that for the enemy as well, but we don't say overlap circle all. We just say overlap circle. This is more performant because we only have one player. But as later, we're going to add some other NPCs to help the player, like, summoned creatures. Then we can use the overlap circle also. It would attack to more than one game object. And yeah, we do something very similar to that. So let's grab it because if you want to learn this, I've told it in the previous sessions on the player attack system. So I don't want to repeat that here. So we have this, and also um, delay. I also add this. Which is the player attack. We also need this one. But as you're learning, try to just write it yourself. Again, by writing again, you kind of practice and learn more. But for this tutorial, I just want to copy and paste it so it wouldn't spend more time. So we have this, and we only say start quarantine. Um, for the attack. And let me go there and define how much damage the enemy would give the player. I think it was integer. So that would be um, 20 at first. And this. And I have to add that to the enemy. So we also need to make a player layer. I make a layer as I told you because we might add more NPCs for someone thing, and I want to label all of them as player. The tag is just the player tag is just for the player, but I can make a layer and call it player and add to different things like someone's being or other NPCs who help me. So I add a layer and call it player or anything that you want. And go here that has a code and add this. All right. As a private layer mask, player layer. Oh, what is that? So everything would be reversed. Not this one to attack. And collider player in this is not players. Just say players. Okay. in here, say player that can get components of the player health bar, which we had the health system here, and we access the take damage of the player health bar, which we had previously set that, and yes, it takes damage. And now we have to declare these things. This is a point, so that is a transform. Serialized private transform. What's the name of that? Attack place or attack point. And the melee range was, I think, what did I decide? It was floats. Damn, I don't see that. Okay, yes. Melee range, yes, it was a float. And Control D, float. Alright, so. And I also want to see that as a circle to test it. It was on a player attack, so I say on draw gizmos, I also bring it here. And then saving the code. So go to your enemy and script enemy AI and drag and drop it here. Sub distance to this player is the player layer. The attack point middle range, something like 2. And add an empty game object and call it attack point, for example. And here, go there and add that. Oh. So that is here. Let's go to attack animation. Oh, that's 2. Let's make the sword to be something like this, so it would have more range. Yes, that's better. So it would be up to here. So let me decrease the attack range. I do something like this and then move the point a little bit here, and yes, that's good. So everything that collides with that. So yes, you can make it, as I've told you before, you can make it a child of the sword. So whatever that the sword moves, it goes there. But we can make also something static like this. Okay, so whatever that comes into this circle that has the layer name, the layer is called player, and it goes there. When the attack animation is performed, then they lose the health. So, okay, we have this. The delay should be when it's, let me go to attack. Up to here, he does nothing, so it wouldn't hurt, but here it hurts. So let me make it. So for different enemies, you might have different speeds, so we can make it serializable and put it here and change for different enemies. So you'd use this piece of code for all of your enemies. You can do that. And now let's go to the animation and add those things, because right now it wouldn't be very nice. Animator, anim, and here say anim is equal to get component animator, and I have to go there here, and in the animator I connect these things. And let's go there. So I put death here, attack here, hurt, and run. For run, we need a boolean. For death, we need a trigger. For maybe you have more than one. For example, you can make your code flexible. Instead of directly say show the set trigger and attack one, you can say, okay, if there is, for example, just one animation, then just show the attack one. If there are two animations, then say, okay, the trigger first, the attack one and attack two. So use a combo system. But for the simplicity, I just use one, and also trigger hurt. What else we have? I think we have all here. Okay. Make sure that it is loop. This is not looped. The triggers better not be looped, and it doesn't matter because it just dies after that. The code is destroyed. And let's go there, move that, move that. Boolean doesn't have exit time, but triggers have. So I make it off. Run is true here. The run is false. And this is a trigger, hurt. The hurt animation would come, and then it goes back to idle. When I'm hurt once, then I want to return to idle. So it has, I want that 90% of my animation would be showed. And let's say 1. It doesn't have anything, it's just exit to idle. From here to attack 1. I'm sorry for the sound that is coming out of the window. Let me quickly say that. So yes, that is this. And make it 91, and this will go out. And then the death animation, okay, when it is dead. All right, so we have set them, and now we can use these values. Here, when it stops, when it is moving, where is that attack? Move towards player. We also want that it shows the running or walking animation. Set bool, and we say that because run is true. All right, but here it has to be false. For example, the player moves away from the aggro or the line of sight, so that would be false because it is not moving, and it shows the, when it goes false, it means that it shows the idle animation. And let's do for the attack, apply damage after 2, but here we say anim.set trigger attack 1. What is this parenthesis? So it shows that. And for take damage and death, we add those hurt and death animation. And also here, it should also be false. And we don't want that the enemy just spams the attack, so I give it a cooldown. So I say serialized fields, private. You can make it just not serialized, but different enemies have different cooldowns, so I added this. So private int cooldown timer is every. You can make it float. Every one and a this second this attacks. And we also have a private float timer to calculate the time. At first it is equal to that, so the enemy can immediately attack. And in the update method we say timer plus equal time.delta time, and we in the attack is done, the timer would be 0. So performs the attack, it is 0. Then it has to wait that, okay, slightly increase the time, and when it reached to that point, then it can attack. And here I also say that if it's better that I add it in the attack. Yes. Where was that? It yes. And timer is more equal to cooldown timer. Then you are allowed to go to this function, which is I have to move these two things to here as well. So the animation is done, but to take the damage, it would have some delays because you have to reach the animation to the point that the sword is moving down. But this should be here. And I think that we're ready to test. First, let me put the enemy far from myself and decrease the amount the sight to 5 and move my player a little bit here. Why it's not moving? Because of that dummy. It has to stop that from moving. There's a solution which I'm going to tell you later, but right now let's get rid of that and test this current code before we add other things to that. No, I think that the problem is... So yeah, the animation are correct. I also should check if the player is dead, it wouldn't attack. So these are the problem that I have to solve. Okay, the problem was due to the animator that controlled the position of the, for example, the enemy, and it always says that, for example, okay, stay here. Or if I try to make a holder, but sometimes this method doesn't work. So in order to prevent the animator to control the position and stick into one position, try to go and just check on the animator, just check apply root motion, and then it is fixed. So now this is moving towards me. I just go there. Oh no. Oh, it killed me. But now it continues to breaking down my body parts, so we have to stop him from attacking when I'm dead. So let's go to. I have to have access to player life. So I say private player health bar and player health. In here, I say player health is equal to this player. Player. What? Sometimes my keyword doesn't write the one. Okay, and then get components. So first we need to go to this game object and then have these components, player health. And here we check. For example, here we say if player health, which one was that? Player health dot is alive. It means that if the player is dead, then just return. And don't execute any of these codes. And that would fix the problem. And also the cooldown, I set it to 2. Because I think 1.2 was too much. But if I fix thing here, it doesn't change it in the inspector, so I have to go and... no, it was not in the inspector because it was not serialized. But why? Cooldown timer. Cooldown, it's here. Yes. So we have to do that. And this is the cooldown. I think that sword damage would be 10. And sword damage to 10. Oh, it suddenly killed me. Why? To fix that, just remove this and in the attack, just paste it here and it's working as intended. So now let's test the game. Okay, here the enemy is not aggroed. I go close to that and then it comes toward me and it's slightly takes damage as I wanted. Okay, let me die here. So now you see it doesn't attack anymore. Right now we have another problem. Let me go to player movement and increase the jump force so I can go on the other side. Okay. Imagine that I'm here. This has not flipped. You see? It's just his back is coming towards me. So we have to fix that as well. So I have to kind of make the enemy to flip when I go there. Imagine that, okay, I can use that by this, as we did for the player. So we can say something like this. If the player is on the left side of the enemy, it shows 1, and if the player goes to the right side of the enemy, it should be -1. But how? You can do that by going to position and X and measure the value. If the position X of the player is more than position X of this, it means that the player is on the right, and it has to scale -1 on the X. And if the position X of the player is less than this one, then it has to do not change. So let's write the code for that. So in the enemy AI, I make a new method and call it private void. And I can say flip towards player, for example, something that is recognizable. And you should say if player player dot transform that position that x is more than the enemy's transform position that x, it means that player is on the right side of the enemy, in the right. So flip, and here we say else, um, or you can say it means that player is on the left. So write these comments for yourself, so later you can understand why do you add that. So it's okay. So unflip. All right. So we go to transform, get the scale. So I have vector 3 local scale, for example, or any name, and then I say transform that's local scale. Okay. Now I say whatever the local scale is to this variable, and then I say local scale dot x would be math f dot apps. It means to make the number always positive, and I say make sure that it is positive. I just make it positive. Okay. Else make that negative. All right. So we use something like this. Okay, I changed that, but I have to give this value return to this. So I say transform that's local scale is equal to this local scale. If you think that the naming is confusing, use the enemy and change them. Something like this. And this is a function that I have to call it somewhere. I have to go to first when the character is moving. So first I want to fix the direction. Also on in the attack. Yes, it's where did I go there? So again, I go there. Increase the jump force. And you see that um, it updates its rotation completely fine. And there's another problem. You see, I can't push the enemy. I don't want to push that. Okay, I gotta go. Bye bye. So how to solve that? The easiest way is that you increase the. See here, the mass of the player is 1. So if I increase the mass of that, it means that it is heavier and I cannot push that. So let it come here. You see, the more that you add this value, the harder that I push this. All right. Up to now, I just told you how you can make the enemy move with transformed position. But you can also make it move using rigid body. And it is good that you do that and it has a rigid body because, for example, the player can imagine that player wants to dash and it can apply some forces and pushes to that one, and they're all done by the rigid body of the enemy. So for the movement we can also use that one as well instead of transfer that position. So that's, I told you, both ways, so you can decide which one fits to your own projects. So let me comment that. And then I say vector 2, that's direction. Use player player that transform position minus transform that position. And we also use normalize so that the speed of the enemy in any direction would be the same. So now we have that. And then we say orbit at velocity. Ah, I didn't get the rigid body of the enemy, yes. So here I say private rigid body 2D RB. And also don't forget to add the real rigid body to your enemy in the inspector. And also define that here. And then you say RB that velocity equals to direction multiply by speed. And then if it move um, towards the player with the speed of, for example, 2. If you want that your enemy just move in the x direction, so it's better that you zero out the here the direction, that's y, to 0, so that it only gets the x position of the player and calculate the um, the direction and then goes in that. But if you have an enemy that, for example, it wants to also follow the player on the y-axis, then you have to delete this. But as I only want that the enemy follow the player on the x-axis, so I just make sure that it is 0, so it wouldn't behave as strange. Now I have this. Let's go and check the game. There is something very important thing that I want to show you. So you see that it doesn't move because if you're using rigid body, you should uncheck that, apply root motion. Otherwise, it would be kind of very complex to apply the rigid body movements or applying force using that rigid body. But yeah, if you have transformed that position, that's we can use that, but not for the rigid body. So why did we at first added that? Because we accidentally in the animation, for example, for the run, we accidentally changed the position of the game object that already has the animator. So don't do that. If you have a game object that has the animator, don't tweak the position of that because it will be fixed just in a, you know, in a stable, in the same position. And it cannot move its position because you said, okay, just stay, for example, in here. This is a solution that works for me, but if there are other solution, I don't know, but this worked fine. So for that, I just delete that and I make sure that it's worked fine. Okay, and I did that, and even if I use transformed position, I don't need to check that. All right, just use that if you make mistake that you animated the position of this, which I have deleted here. So I never use this either for a rigid body or transformed position. And now this should work. Now let's go and check that, and we see that it is working. All right. Now that we have this enemy and everything is corrected, so we can add other variety of enemies. For example, I have this one, and I go to that's where is this? Okay. And I can change, for example, the head. I can change the weapon, or Now I go here. For example, the sight distance, I can make it to 10. The stop distance, make it to, for example, I can change it, but that was because I think that it was good, but you can change that as well. And the speed is 3. For example, a sword damage would be 8. And the range, for example, it attack faster. Now let's see what happens. So it has more line of sight. Let me show you something here. Do you see that? Oh, I have to go very slowly. This is moving, but this is not. And he pushes him. So these enemies kind of collide with each other. I don't want that to happen. I want that, for example, it can pass through that. If I disable a collider, it just falls down. So I want to make sure that those things that are on the enemy layer, they are not colliding with each other and they can pass through each other, but they collide with the earth, for example, so they wouldn't fall down. To solve that problem, we use something called collision matrix. So go to Edit, Project Setting, Physics 2D. Usually something like this happens, but as it is 2D, go to 2D and go to this tab. We have Layer Collision Matrix. Here it says, for example, player with the enemy they collide, okay? And you see something appear, player and enemy player. Yes, they collide. But enemy, I don't want that they collide. Okay, so now let's see what happens in the game. It can easily pass through that. But did you saw that when he was passing through him, some layers um, were weirdly overlapping with the layers of this? You see? Oh, it's kind of weird. So, for example, you can make one of them. So select all of them, not the folder that doesn't have a sprite renderer. Here, for example, you can say all of them to 1. They're on the same sorting layer, but ordering layer, just change that. So all of them, for example, comes um, in front of this enemy. Or if I want to make it back, just say -1. So it depends on your preferences. Now it moves good. Another thing that I want to add to the enemy AI is that, just look at this, when I come here and there's an obstacle, they just run in their place like an idiot. I just want to make them to be smart enough that if there is an obstacle, they can jump and follow me. All right, so for example, if I go here, they wouldn't be stuck here. There are many ways to fix that, but the easiest one is using Raycast. You remember that for the player, we use Raycast to detect the ground, that the ray just, an invisible ray comes from the origin of the player and hits the ground, and it's okay, it is grounded. We want to use that same logic for this enemies. For example, but instead of the Raycast going down, it goes, for example, in this direction. And if something is that direction, like a wall, like something like this, in the for example, in this specific layer, then it applies force on the y-axis, which is the jumping function, and it would jump. So let's do that. So first we need to use the layer mask serializable, serialized fill, private, layer mask, ground. You can say obstacle, anything, okay? But We use the same thing because our plane and our platform is on the ground layer. Okay, so we don't need to add some obstacle layer, unless, yes, it's good to have that, but that is one tile, so we cannot actually separate that unless that you want to, for example, for the smooth layer use another tile, and for this bumping use another tile. I don't know, you can use that, but this works good if you just use one tile map and just set it to the ground. So if the raycast goes down, it is used for checking if it is grounded for jumping, and if the ground is in front of that, you know, then that would first it detects that it is an obstacle and jump on that, something like that. So it works good. We have that, and then for the player movements, we have is grounded. No, we can use that for the enemy as well. So go here. I don't need that. And also it was ground, not with a capital G. Okay, so this is for checking if, like before, it's nothing new about that. So, so it wouldn't spam jumping. I did that because of that. And then we got to move towards the player. And here, we use the same thing. Physics.d. So for some raycast hit 2D, hit is equal to that line, but instead of down, we want that it goes to the front. Okay, but for example, when the enemy flips to that direction, the raycast goes in that direction, and when enemy is facing in that direction, the raycast should be in that direction. So I have to apply the localized scale as well, because as you remember, when an enemy wants to face in that direction, we change the this value. So I need that the direction, which is transform that localized scale, that x, whether it is -1 or 1. But as you saw, that our model was kind of reverted. We say, oh, sorry, because it looks in that direction. So all of these signs are kind of working in the opposite way. So for my case, I need to add minus as well. Okay. Now we check if hit is is not null. It means that it has hit to something, and or we can say yes. Then we check if is grounded. Then we do the jumping. We can make another function and add the jump, but I just add it here. Be that velocity equals to new vector 2 rb, that's whatever that is x. We just want to add the y, for example, give it 10 on the y-axis, so it kind of jumps. You can also use rb.add force if it hits that. Else let me go here because we have that. Else, okay, move and something that we had before. So it didn't hit to anything. It means that nothing is in front of that. Then you have to go to the y-axis because and the x-axis, because the y is 0 and just gets the direction, and then here it moves. But if it hits to something, it means that something is in front of that. Then it has to jump, and you can also add the jump animation, which I don't have, but I'm going to make that anim.set trigger jump. Well, let me first comment it because we first want to try this code. And excuse me, hits that collider. I forgot that. Okay, so this is correct. So here, don't forget that you add ground to ground because our platform is in the ground layer. Now let's check this. So I go close to move in that direction. Um, Maybe we need to add to that number. Just play with these numbers so you can get the better results. Okay, so yeah, they cannot. Oh, no, no, no! Let me go away because I want to check the other side as well. Okay, I have no way but to. No, no, I don't want to go. So let me increase the jump power of mine. Jump force, just temporarily. I will increase the decrease. If I stop the game, it will reset. Okay, so I'm here. Just jumped and came and follow me. Oh, but look. So to fix that, it's better that we, instead of this, say new vector 2. It was direction.x multiply by speed and rb, that's velocity, that's y. That's better. And I added the animation, I added jumping is here, something like that. And don't forget to add this to this. So let's make it more natural. Let's add the gravity scale to 3. And if this is not enough, then you have to the jump force. Where is that? I didn't make it serialized. No, so let's go and make it serializable. Because it's very hard to just return here and change it. No, I didn't do anything. I just took 10. So I say jump force and go here. Private int jump force is 12. Now let's so I change it to, let me change my jump force to this, and yeah, just make it gravity scale 3 and jump force 14. And also try not to make your walls very very long because they cannot jump from that. Also, do not make jump force of the players so much that they can easily jump on top of the head of the enemy, because the player would dodge all of them and goes to the end of the level. Say is that yes, you can duplicate, make a prefab out of this, and if anyone replaced it, yes, when I do not play the game, it is rotated this way. So do not change the rotation, because when the game starts, it automatically corrects the rotation. Okay, so now we have this. Yeah, that is for now. And there are different types of enemies. For example, we have mage, or that the mage can fly, or for example, we have something okay that doesn't move but can shoot something. I think that I cannot cover them in this session. I will talk about them in the next session. These were the most common enemy AI that I've told you. Yes, there are other things that you can add. I cannot talk about all of them because if I want to, we have to spend all day talking about different possible AIs that you can give to your enemies. For example, you can make it to block your attack. You can make it okay when it hits to somewhere that is like a cliff and doesn't have anywhere to go in between. It can jump on that. Or, for example, the enemy has a health system if you're going to use that. But imagine that, for example, if I have 100% health, it would show some certain attacks, but as it loses health, for example, the attack rate would increase. So there are different things that you can figure out and add to your game. You know the codes, but you add the logic to that.